Good afternoon, class. Today, let's start Chapter 5. Lesson 1, the concept of set. Sets are mathematical objects. It has a clear definition. Look at the definition. A set is a collection of well-defined and distinct objects. The number of objects in a set is denoted as n bracket A. For example, A equals to 1, 2, 3, 5. This is a set. The number of objects in this set is 4. Moving on. Element. An element is an object in a set. In this example, 1 is an element of A. So is 2, so is 3, and 5. There are too many methods when it comes to describe a set or to denote a set. There are listing method and description method. Listing method is simply to put all the elements inside a bracket like this. For example, set C equals to 4, 2, 1, 3. Set D is a set of colors, red, blue, and green. Description method is like this. In the bracket, first we put down the variable we want to use, and then we put down a property of this variable. For example, set A is equal to x, where x is smaller than 2. Set B is equal to y, where y is a square number. You can see that if we have very few elements, it's better to use listing method. Otherwise, it's better to use description method. There are some aspects I want you to note. First, the elements of a set can be anything. Really anything. It can be numbers, can be people, letters, other sets, and so on. In fact, the only thing it cannot be is the set itself. Note number 1. Using listing method, the order of the elements are not considered. For example, in the set C is 4, 2, 1, 3. You can also write 1, 2, 3, 4. It doesn't change the set. Number 2, there cannot be repeated elements, meaning that you shouldn't write the same element inside a set twice. Number 3, using describing method, the column means such that. For example, A is a set of numbers x, such that x is smaller than 2. Number 4, using describing method, the property of X must be definite. For example, X such that X is a large number is not a well-defined set, because a large number is not definite. I'll give you some example. Example 1, list all elements of the following sets. First set, X is theta, where cosine theta is 1/2, and theta is between 0 degree and 360 degree inclusive. So in this case, theta can be 60 degree or 300 degree. So X can be, using listing method, 60 degree, 300 degree. Y. Y equals to the LCM of 6 and 15. So the LCM is equal to 30. So Y equal 30 in bracket. Even when there is only one element in the set, you must put the bracket there to indicate this is a set, not just an object, not just a number. Z. Z is a set of 7 continents. So if I remember correctly, Asia, Africa, North America, South America, Antarctica, and Australia. You should put all the objects inside the bracket. Moving on. If A is an element of set A, we can say that A belongs to A. This symbol means belong to. If A is not an element of set A, otherwise, A is not an element inside A. So we use this symbol that means does not belong to. Look at the example. A is a set of numbers 1, 2, 3. So 1 is an element of A, and 5 is not an element of A. 1 belongs to A, 5 doesn't belong to A. Quick example. Consider A is 1, 2, 3, 5. 1 belongs to A, but 4 does not belong to A. 1 is an element of A. 4 is not an element of A. This is the relation between an object and a set. Moving on. If for every element in A, for every element in A, for every element in A, it also belongs to B. In that case, A is a subset of B. The new word subset. This is denoted as A is a subset of B like that, or B like that. If you write B in front of A like that, meaning that A is a subset of B. What does that mean? that means this. You see, for example, set A is 1, 2, 3, 5, and set B also contain the same numbers 1, 2, 3, 5, and more. In that case, every element in A also belong to B. So in this case, A is a subset of B. You can also understand it like this. So B is a larger area and A is part of it. Meaning that every element in A also belong to B. Moving on. The next concept, empty set. Empty set is the set which has no element. It's like a box without any content in it. This set is a special set. We use a special symbol to denote it. An empty set can be written as this, just the bracket with nothing in it. Or you can use the letter phi, like that. It means a set of nothing. A universal set is just the opposite. A universal set is the set which contains all elements. It's denoted by S. Obviously, when we talk about different issues, the universal set can be different. For example, if we are talking about numbers, the universal set should be all the numbers. If we are talking about colors, then the universal set should be all the colors. It depends on what our topic is. Note number 5. Please pay attention. This set is not an empty set. It is a set of one element 0. Moving on. The next concept, intersection, union, and complement of sets. What are they? We consider these three as the operations that we can do within sets. But first, let's take a look at what is an equal set. Two sets are equal if and only if they have precisely the same element. For example, 1, 2, and 2, 1 are equal sets because they have the same element. If one has more element than the other one, or even just one more element, they are not equal. Well, they must be exactly the same. Then, what is the union then? Union is the result when you put two sets together. What do I mean? Look at this definition maybe. It's easier to understand this definition. Sorry, this is the intersection. It's easier to understand this definition. The set containing all elements of set A and B is called the union. The union is denoted as AUB. Example, set A, 1, 2, 3, 4, 5, set B, 1, 3, 5, 7, 9. So if you union A and B, AUB is equal to all the sets in A and all the sets in B. you put them together. If some element occurs in A and B at the same time, don't write it twice, just write it once. Okay? That is the union. Also, the definition in symbol, you may be interested. This one is not in the textbook. The definition of AUB is equal to variable x such that x is A or x is B. X belongs to A or X belongs to B. Next concept, intersection. What is the intersection between two sets? Let's look at the easier definition here. Let's read it. The set containing the common elements of two sets A and B is called the intersection, denoted as A intersect B. This symbol means intersect, also read as intersect. Example, A is A, B, C, D, E, and B is A, E, I, O, U. So what is A intersect B? It means that if this element occurs in A and B, then it belongs to the intersection of A and B. In this case, A and E. Let's take a look at the definition of intersection in symbol. If you do not want to write a whole paragraph of this is the definition of A intersect B. The A intersect B is equal to a set of X where X belongs to A at the same time X belongs to B, meaning that I should take out all the elements that belongs to A and B and put them together. So union and intersection are the two operations we can do within two sets. Lastly, complement. A complement is considered as the opposite of that set, is denoted as prime. The complement of A is A prime. For example, look at this example. If the universal set is 1, 2, 3, 4, 5, 6, 7, 8, 9, and A is 1, 2, 3, 4, 5, then the complement of A prime, is the rest of the numbers. Please note, number 6, A and A prime, the intersection should be empty set. A and A prime, because they should not have any elements in common. Number 7, A union A prime. A union its own complement should equal to the universal set. Take a look at this example, you will understand more. Number 8, the complement of A is A itself. Look at this. A is 1, 2, 3, 4, 5. The complement of A is 6, 7, 8, 9. And the complement of that will be 1, 2, 3, 4, 5 again. So a little bit something here. Example 2. Universal set is 1 to 9. A is 1, 3, 5, 7, 9, and B is 1, 2, 3, 4, 5. Find A union B. A union B. It's quicker to just write 1, 3, 5, 7, 9. All the elements in A. And then write all the elements in B, but avoid repeating. So 1 already there, and 2, 3 already there, and 4 and 5 already there. So this is A union B. It doesn't matter the order of the elements, like in what order you put them, it doesn't matter. So that could be your final answer. But of course, it's nicer if you can put them in a certain order. It's just easier to look at. But this is not wrong. Moving on, how about A prime, the complement of A? So I just write everything that's not in A, but in S. So 2, 4, 6, 8, complement of A. Complement of B, 6, 7, 8, 9. Next part, A complement intersect B complement. A complement intersect B complement. That means this intersect this. 6 and 8. They have 6 and 8 in common. Next one. A union B bracket and then complement. A union B bracket complement. It means this, the answer of A, 1, 3, 5, 7, 9, 2, 4, and complement. And that will equal to 6 and 8. Okay? You can finish the classwork. You can pause the video and finish the classwork. And check your answer with me. Okay, welcome back. Let's look at another very important aspect of the set theory. It's called the Venn diagram. A Venn diagram is a visual expression of sets and the relation among the sets. For example, this is the universal set, one set, and the other set. And this is the Venn diagram of these sets. You can use a large rectangle to represent all the numbers concerned. That means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the numbers. Set A is represented by a circle. And inside the circle, you have all the elements 2, 4, 6, 8, 10. And this is all the elements inside B, 2, 3, 5, 7. And here you can see there is an overlapping part, meaning that the intersection of AB, and there is a common element in there, 2. There are also two numbers that don't belong to A or B, 1 and 9. So we put it there. So this is the Venn diagram of these three sets. More example about this. Suppose S is the universal set and A and B are sets like that. This part in the middle, the overlapping part, means that A intersect B. How about A union B? A union B means take all the elements in A plus all the elements in B, including the overlapping part. This is the complement of A, represented by the shaded area. This is A union B prime, A, all the elements in A and all the elements in B prime, including the overlapping part. This one, A intersect B prime, A intersect B prime, A prime intersect B. Next example. Refer to the Venn diagram. Find each of the following sets. First, A union B. A union B is all the things that's in A and all the things in B. And Li, we don't have to write it twice. So Chen, Wang. A intersect B. I cannot stress more, you must put the brackets. Universal sets. Chen, Li, Chen, Wang, and Hou. A prime union B prime. A prime. A complement. That means everything here, A complement, union B complement. That means everything here. So I'm thinking A complement, B complement. So Chen, Wang, Hou. Lastly, A prime union intersect B prime. A prime, that's this part, intersect B prime. So in the end, it's this part. Only the outside, right? Yes. Okay. Next example. Use a Venn diagram to show the relationship among the following sets. A intersect B is P and Q. A union B, PQR C. A itself, PQR S. PQR STUV. Let's try. First, use a large rectangle to represent S. All the elements are there, but I don't know where to put them, so I will draw the circle A first. PQR. And circle B, the intersection should be written here. A has PQR, so R should be here. A union B has PQRST, so S and T must be here. And then the rest should be outside A union B. U, V. To check, yes, this is the Venn diagram of these three sets. Okay, that's the end of the lesson. Please proceed to the Google Classroom to find out the homework for this lesson.